So what I'm going to talk about today is a technique that over kind of a number of years I developed to manage my BU students who do projects in teams to get them to be a lot more successful. And I've incorporated this in my own software development work, and it turns out it works pretty well. So I'd like to share with you sort of this whole idea. And it's based on something called unknowns. I call them unknowns. Don't jump to conclusions about what I mean by unknowns. I'll define them. But they may not be exactly what you might be thinking. But it's fortunately not a particularly complex concept, and it's very easy to experiment with. So we start first talking about who I am. I've been doing software development for a long time. I think I started programming when I was about 14. I guess I shouldn't tell you how old I am, but I guess I'm at least 44. So I've been programming for a long time. I do a lot of digital related things, like Paul mentioned. I also do photography. I find photography to be, in a way, technically quite similar to software, but I digress. I've taught software engineering at BU for 9 years, mainly a class where it's project-based, team-based, and it's where I had for this opportunity to kind of discover and refine this idea. I still do a lot of software development. In fact, I'm doing a project right now, kind of an interesting one where about 15 years ago I wrote a system for, I won't name drop, so I just won't name drop, but it's for somebody relatively famous who I developed a window-based system for them, and I'm now creating a web-based system for them. And I'm using this very technique, using unknowns, to manage the project. There's a number of people involved. I need to know where things stand, and I use this technique to communicate very clearly with them. And I also privately mentor aspiring software developers. In fact, I'm kind of transitioning out of BU, and I do it online. In fact, there might be some people here. Well, last June I did a little, about a 6-week program where I mentored them. We didn't cover everything. I've got a class that started in September, this graduating now. I do it entirely over the internet. It's kind of a really cool, but I use Skype or Google Plus and screen sharing, and it's incredibly effective. But rather than having a huge class, even you guys would be a huge class, it's usually only 2 or 3 people at a time when we do screen sharing. It's incredibly effective because you can focus the conversation. Once again, I digress. Anyhow, so, but I teach what I've taught. This, in fact, is kind of a portion of what I teach. All right, so I'm going to talk specifically about this course that I've taught at BU, and specifically about the project success there. And if these little faces represent groups in a class, usually I'd have about 9 groups in a class. And early on, there'd be, at most, maybe 2 groups that would actually deliver a working product that I would define for them to develop over the course of the term. And most everybody else would fail. They would have nothing, or something that was very poor. And later on, the tables kind of turned. Most everybody succeeded. And there was always, unfortunately, some groups that no matter how hard you tried to get them to succeed, they managed to find a way to fail. So, but it was kind of a pleasant situation because most every group had something that they delivered that worked. The last class of the semester, they actually had to present to a panel of outside people, very much like yourselves, who would interrogate them about their product, and they had to demo their product. And so it was, if you didn't have a working product, it was a pretty awkward class to attend. So, but in any event, the tables turned. We had mostly successful groups. And the question is, what changed? And what changed has to do with actually a serendipitous event. In this very room where this photo was taken, after the class ran from 6 to 8:45 in the evening. And so a lot of times after class, I would go into this lounge and begin preparing for next week. And some of the students would also go in there and start doing their homework. And so I was kind of eavesdropping, not on these guys. There's another group like these guys, but they kind of resemble them in the sense of concern on their faces. But it's pretty close to the time the projects were due. And I was going eavesdropping, I was going like, these guys are just starting to listen to the types of things. They're Googling this, Googling that, because I've given them a description of the product, and the product had a lot of different kind of facets to it, technical facets to them. And they didn't know how to do any of these technical things. And they're sort of like in a bind. They needed to figure out how to do this stuff. So they're Googling like mad, trying to write a little script or something to try out what they read online. So this kind of gave me this flash of insight, which when something like that, they should have been doing this months ago. Okay? And I sort of wanted to, I guess maybe I was, well, you know, I was kind of thrown into this teaching thing. I didn't have any formal training as a teacher. So, and BU said, well, you know, give them projects. And so I gave projects, and I didn't really try to manage them much. And so this is kind of what happened. But this, even though it was kind of obvious that they should have been doing this months ago, this particular event that one evening kind of struck home that there was something that they should have been doing all along. And specifically doing what? They should have been identifying things they didn't know, which they were doing in that meeting. And on top of that, then they not only need to identify what they don't know how to do, they need to kind of resolve these things. They need to, if they need to know a language, they need to write some code in that language to be able to code up the product. In fact, the projects, it was kind of interesting that most of what they had to use for the project, most of the class had no prior experience with. We're using things like MySQL, PHP, Perl, JavaScript, and it was really amazing that most of them came into the class knowing only Java. They didn't know C. They didn't know anything about web development. So they had a lot of things that they didn't know how to do, and they had a lot of resolving to do. And they had to do it, it dawned on me they needed to do it well ahead of time. So this, I kind of committed myself that sort of in the future I'd manage the projects a little differently. And let me give you some examples, by the way, of things that this particular group was talking about. Things like how to get a browser to send data to a server without refreshing. How many of you guys know how to do that? A couple? Okay. And how about how to send, this is an easier one, how to send an email with a server script. Okay, well these guys knew, they were way behind you guys. Another funny thing is actually, they weren't writing the product from scratch. I gave them an existing product. Because very early on, I had a really bright student that implemented a system that was assigned. And he did a pretty good job. He was like the one member of the group that actually did all the work. But he did a pretty good job. So then from that point on, I used his implementation as the legacy code. So I was trying to make this as realistic as possible. So they didn't get to start from scratch. They had to start with legacy code. And these guys, I was listening to them, it's like they didn't even know how the existing legacy code worked. And they had like I think it was probably less than a week to finish their project. And even though they had all 3 months, they waited until the last minute. And they were sort of almost, desperate straits trying to get their heads around what the product code did. The really good one was, I had like a lot of detail about what I wanted, what enhancements I wanted to this existing product. And they were reading through that, like sounding like for the first time. So they had all these things that they needed to resolve that they didn't know, and they waited until the last minute. And there are a bunch of other things that I won't bore you with. Maybe this might not sort of convey sort of kind of the flash I felt when I said, wow, I now know how to manage the classes. Question?
Curious, what were they doing 3 months ago or 2 months ago?
That was a good question. I sort of, my approach with with my teaching is to kind of treat them like adults. So I'm not going to chase them around. So it was sort of against my nature to say, are you working on your project? Are you working on your project? you know, I'm sure that, in fact, I know in my announcements right before lecture, I say, remember, the project is due, you know, May 15th. You know, but I didn't harass anybody or kind of remind anybody. I simply,
So you didn't have stand-ups?
we didn't have stand-ups, no. But I'll get into sort of eventually what happened. In any event, this, for me, this kind of, I felt it was profound, but that there are all these things. I guess being a developer, I'm a person that likes categories. And all these things that they were talking about fell into like what the customer wants, what the existing code does, how to do various technical things, even what the user interface should look like. These all fell into a single category, which seemed to have no better name than unknown. These are all unknowns. Like, so it wasn't just the code, it was what the customer wants, what the user interface should look like, what the existing code does. So, and once this kind of clicked, I sort of, it dawned on me that, you know, how to, you know, a better way to manage the groups. Because we would have occasional meetings, to be honest. And it would be those meetings where you don't really know where things stand. They go, yeah, doing well. You know, like, have you looked at my write-up for what, you know, the enhancements should be? Yeah, well, we're going to do that this week. You know, stuff like that. So anyhow, so your reaction might be so what? To me, it was kind of profound. To you, it might be so what? And here's kind of what the big deal for me was, which I'll kind of explain with a thought experiment. You're a software developer. You're assigned to make some changes. You know nothing about the existing code. You vaguely know what the customer is asking for or needs. You need to get up to speed with the technology. Also, you have no idea what the user interface should look like. How likely is this to end successfully? So this was the state early on. And they kept themselves in this state, and it was no surprise that usually 7 out of 9, 8 out of 9. I think I had terms where nobody had anything working. So it was kind of an unhappy kind of ending for the course. Now I'm going to flip this around where you're fluent with the existing code, you understand the customer's needs and wants, and not that the customer, once again, the customer doesn't really know. I don't unfortunately have time to get into the technique that I used to, let's see, the technique I taught the students to talk to the customers with, but that's a whole other presentation, which some of you may be familiar with. It's the concept of scenarios and use cases and having the customers review them, and the customers will always tell you what you got wrong in the use cases. They won't write the use cases. They won't necessarily tell you what you got right. But should you get something wrong that they don't want, they'll tell you right away, which turns out to be pretty much most of what you need to know. And then on top of it, you have experience with the various technology you need to build a product. And on top of that, you have a user interface design, which is it's quite common today to have a user interface, user experience expert design user interface. So you as the developer don't have to make any of these decisions. You implement it in a fixed and perfect way. And I imagine you guys would agree this ends has much more likelihood of a successful ending. So the unknowns were kind of a key to getting from the previous routine to this routine. And so what's different is the amount of knowledge. It was not the code. Actually, a misconception about software development, which actually software developers themselves hold. How many people write code? A lot of you. So you might understand what I mean. That a lot of people have this conception or misconception that the important thing is to write code. You know, if you've got the code written, you're in good shape. But it turns out, what's really key is to understand what the code should be based on. If you understand that and you lose the code, you can recreate the code. If somebody gives you the code, but you don't have the knowledge and you lose the code, you're screwed. Okay? The key is knowledge. So what I ended up focusing these students on was gathering all the knowledge they need. I said, don't worry about writing a lot. Well, don't worry about writing the product. we'll talk about sort of how much code they wrote, but focus on gathering the knowledge. And before you do that, identify what you don't know, these unknowns. So if we're in situation 1, get to situation 2, we need to gather knowledge. What knowledge? Everything you need to know to carry out the project. What the customer wants. And you need to know in pretty clear detail, and the challenge is the customer doesn't really want to give you that time and cooperation. So you end up having to do a lot of the work. But there are ways to extract this information pretty effectively. Another thing is what the user interface should look like. That's a huge one. A lot of people, I've been on projects where like they say just make it up as you go. And it just ends up invariably horrible. You need to have that designed by somebody who really has a feel for what people will find intuitive, easy to use. So that's knowledge itself, what the user interface looks like. And a really huge one, actually, what the existing code does. Because, in fact, most software development is done in the context of legacy code, almost all of it. In fact, there's a Microsoft, the person who was the tech lead for C# says that all code is legacy code, because even if you write some fresh code, go get a coffee, come back, you're working on legacy code. And if you don't understand what the code does, you're guessing, oftentimes, what an appropriate change is. You're hoping that, well, if everything passes the test, I did things properly. So the knowledge of not just the code, but the ideas underlying the code are a huge portion of the knowledge needed to carry out a project. Because if you're modifying the code, you're modifying those underlying mechanisms or those concepts, and you better understand clearly what those concepts are, or you'll be introducing nonsense. And isn't it obvious that you need this knowledge? Apparently, to my students, it wasn't. Well, I guess when you're 18, 19, 20, I think you can kind of whack and hack and get the thing done quickly and you can probably figure stuff out quickly. But it turns out that even in the professional world, I've seen situations where somebody gets a project and it's a form of denial. There's all these things they don't know how to do, but they kind of conveniently ignore them and immediately start working on some little thin slice of the whole thing. And they don't realize that they need knowledge in a lot of different areas to make the whole project successful. So even for professionals, it's sometimes not obvious that they need kind of a pretty large collection of knowledge to make the project successful or complete a project. All right. Yes?
I have a comment. But with agile methodology, the tenet is to go ahead and fail quickly or to get something done early on.
Mm-hmm.
So basically, what you do know, trying to get it down and get it done.
First of all, this concept is entirely compatible with Agile. And once again, that's a kind of another presentation, but I'll just kind of connect it quickly, that user stories are basically statements of capability. And when you look at the statement of capability, it has all these different aspects of it. I need to know how to access the database. I need to know how to implement the user interface. I need to know how to do something over a network. And so those are the unknowns underlying that user story. So the work that you might plan for a sprint might not be that user story, but some of the unknowns underlying the particular user story. So it's completely compatible with Agile. By the way, I don't believe waterfall can ever be made to work. Okay, largely because software development is an iterative process by its nature. There are things, in fact, you won't be able to identify all your unknowns at the beginning because some of them become apparent only once you've started resolving some of them, and then you discover other things and other things occur to you. So it's an iterative process, but there are a number of different iterative models, but this is completely compatible with any type of Agile that you would try to attempt. Okay, so before unknown, BU, okay. Students would get a project assignment. They'd immediately start writing code. These kids that I was listening to, they were Googling and they weren't writing little scripts to say, okay, now I know how to do this. They were like, okay, we need to send some, it turned out that the registration had to send an email. So they were already implementing, sending the email from the registration, and this is going to be their product. They're actually working on their product. And it was always whack and hack. But they're aiming already to write the product code. And at the end, what I typically hear, well, we couldn't get it to work. Why why am I not getting an email? Well, no, it didn't work. And so this is after unknowns. They get the project assignment, and this is where we started having much more regular meetings. But the initial meetings were about what don't you know. I didn't want them writing product code. I didn't even want them resolving any of the unknowns. They had to identify, in fact, it requires a lot of discipline to do this properly, which is to spend time to think of as many unknowns as you can before you start doing any work. Part of it was because I wanted them to come up with an estimate of how long they thought this was going to take. And if you don't have an idea of all the different technical things you're going to solve, or if you don't, well, not all, but if you don't have a sufficiently complete list of all the technical issues you need to address, I guarantee you're not going to budget enough time. I'm sure you can relate to projects where unexpected, quote unquote, unexpected things came up at the end, largely because people really didn't want to think hard enough about, well, gee, we're going to need to be able to do this, or we're going to have to do that. So we spent a lot of time early in the term just talking about what they didn't know. And usually, not usually, always, there's pages and pages. Yes?
How is this different from, say, a formalized risk management plan that along the lines with the
It's
SEI?
kind of related to that because you can then assign risks to each one of these unknowns. For example, if you need to develop an algorithm, which nobody has ever developed before, there's a certain risk aspect to it, and then you can weight that more heavily in your risk analysis of the project. Is that sort of the direction of your question? Where some of the things are, we just, we need to export the content in PDF format. Well, how do we do that? With a library, that's a relatively low risk solution. Yes?
Yeah, can you say something about assumptions that people are working on and what they don't know that they don't know? Does that seem that would play into
I didn't allow anything to remain an assumption. You had to say what you didn't know.
Did you have to say what you assumed?
You could initially assume it, but eventually you had to demonstrate that your assumption was correct. If they couldn't assume that they knew how to export to PDF, for example, they had to show me a little program that exported to PDF. So then I knew that they knew how to do it. There was nothing where they were allowed to say, I assume I can do that. Or, I read somewhere that, you can send emails with a server script. Nothing was allowed to be left in that state. They had actually, the meetings that we had in the middle of the term was they had to demonstrate to me that they had little programs that demonstrated these various capabilities that they claimed they knew how to do. Nothing went kind of untested. So does that answer your question? Or I know eventually, life has boundaries. You have to assume something, but very little. There was nothing that I allowed them to say, yeah, we know how to do that. So they had to show me they knew how to do it.
So how do you estimate what you don't know and how long it can take to know it?
That's another presentation. Unfortunately, there are things that you don't know that you don't know.
Right.
Those things, unfortunately, are in a blind spot. The things that you know that you don't know. Once again, I'll do a small digression here, is you reduce it to a list of tasks. What do I need to do to figure this out?
Right.
And from those tasks, you usually can get a fairly, I wouldn't say accurate, but you get a sense of what this is going to take. And the funny thing was, when I had the students do this, they were always like, no, this is way too much time. You know, they always thought, you know, that the numbers that from this calculation. They said, well, you know, if you need to go and, you know, implement, you know, some sort of sorting or something, you can't say it's going to take 0 time. You've got to provide, allocate some time to do that. They're always amazed how long this ended up, the calculation predicted it would take. But the funny thing is, they're also surprised how accurate at the end of the term, when they look back, I made them look back at their estimate. They're amazed at like how accurate these calculations were, but it was no surprise because they took into account the things they had to do. That makes sense. Question?
After a while, as an instructor, you kind of knew the things that they didn't know, or that, and so suppose a particular group identified what they said they didn't know, and you knew that there were other things they didn't know that they hadn't identified yet. Did you intervene or just let life happen?
I very subtly nudged them, but I didn't do their work for them because part of the work was to sit there and think hard about what they didn't know. So that's a good question. That it's a skill just like the software development or programming. You need to actually kind of try hard. And it gets easier. I find it pretty easy at this point myself to do it. But when you first sit down to do it, you go like, can't think of much. And that's what they would do. They'd want to rush into the programming, which was kind of the fun part. Right. So then the next stage was to actually gather knowledge, was when, sort of demonstrate not only that you think you know how to do it, show me that you do know how to do it. We would have these very fast, in fact, kind of like stand-up meetings. We never called them stand-up meetings. They're about 5 minutes. You had 5 minutes to demonstrate your thing. So it wasn't a drawn-out, lengthy discussion. If you are supposed to export something to PDF, come to my office. You have 5 minutes to basically tell me what you're planning to demonstrate it, show me that you know how to do it. And incidentally, they had to give me a long list of their unknowns. So I was working off their list, checking it off, and they weren't allowed actually to proceed to developing their product until their unknown list was completely checked off. So, but with these little 5-minute meetings, we were able to kind of see that they knew what they were doing, and when all their unknowns were checked off, they were able to proceed and work on the product. And gathering this knowledge involved writing lots of code. In fact, I do a lot of this. I write a lot of little programs instead of working on one big monster program that has all sorts of things in it. I'll write a lot of little programs just to kind of convince myself, yeah, I know how to do that. And if something when I'm working on the product doesn't work, I can always go back to the little program because I know I got it to work in the little program. So why isn't it working when I'm developing the product? So they ended up writing lots of code. In fact, the bulk of the code that they wrote was during this phase. Because not only did they write these little programs, they also had to create test harnesses, mocks, stubs, things like that. So they were basically creating little pieces that are all insulated from each other, which allowed them to work much more quickly in parallel. One person wouldn't break somebody else's code because they're all working on one big pile of source code, which was one of the problems early on also. They were writing a lot of stuff that ended up not in the product, but made them work a lot faster. And then eventually they were given what was called the green light to write the product. And it was only once I knew that they knew all the key things they needed to know in order to produce product code. And they could borrow from the stuff that they wrote while they're gathering knowledge. It wasn't like they had to write it from scratch. All right, so what I want to do is now address a couple of things here in a little more detail. By the way, most people ended up writing product code that was quite nice, and they wrote it quite quickly. And I want to talk a little bit about how I developed confidence that you could put off writing the product code until near the end and still get your project done. How many people are managers and would allow a developer to start working on the actual product kind of late in the schedule? Right. It takes a bit of faith. But the thing is that for the most of the project, they've been writing kind of these scrap programs and showing you that the algorithms work, the connections between the servers work, and kind of giving you the confidence that they know what you're doing. It's kind of easier to have faith that they're going to be able to put together the product. It's not saying that there may be some integration issues or whatever, but it's sort of contrary. This is actually where this kind of differs from Agile. Agile sort of has this, at least most of the Agile environments I've worked in, they have sort of this notion that we need to kind of build up the product, and as we're going, we're safe. We've got part of the product done. We keep accumulating the product. Where this is, you're accumulating the knowledge, and then you create most of the product code at the very end. And so this is, in fact, how do I know? Actually, it goes much further back than my teaching at BU. There are two particular incidents, but there's more than two that stick out in my mind that were kind of personal experience as a software developer. And one I entitled "It's easier to apologize than ask for permission," which is kind of one of those cliche stuff. But this is back in the 80s. I was relatively new to software development, and I was working for a company that had a relatively prominent product, and that product had a feature that was very, very problematic. And they'd had a number of developers try to fix the code for this feature, and it always ended up being full of bugs. So I was finally assigned this every kicking this thing around, and I ended up with it. And I convinced my manager, we have to rewrite this. And after a while, he was one of these guys that was somewhat scared of his management, but reasonable. He took a chance. He said, okay, rewrite it. And so I spent about 3 months rewriting it. But as I was rewriting it, and in fact, well, the feature had a lot of different algorithmic issues. I don't want to get into the technical details, but there are a lot of different aspects of this feature where the failures occurred. So there are a lot of things to consider. Like, in fact, the main question I had to answer was, how should the software function in this particular situation? And the problem with this particular feature was it had lots of those places where you have to ask that question. So I spent about 3 months kind of working out how the software should work in each of those situations. And I was writing code. In fact, the mentality I had at that time was the code I'm writing is going to be the product code. But I was writing code to convince myself that my ideas for how this situation should be handled, that situation should be handled, I just needed to convince myself that yes, it was going to work the way I thought it was going to work. So I started in, I think, August, and I remember it was the weekend before Thanksgiving. And that Friday, it ran through, it was probably 500 tests, and they all worked. And went to my manager and said, in fact, it was pretty much within the budgeted time. I said, it works. And he says, ship it. I go, well, not so fast. It looks good from the outside, but inside it's kind of a mess. We're going to have to live with this. I want to rewrite it. He was horrified. I said, no way. But fortunately, it was a Friday. Okay, I wasn't married, didn't have kids. Okay? And had a weekend. So I started working on it Friday afternoon, and by Sunday afternoon I had rewritten the whole thing. And this was, I want to say, it was probably over 100 files of source code, and I did borrow stuff from the existing stuff and kind of refactored it. But the thing was that I didn't have to learn anything new. And the really amazing thing was after a few cleanups, Sunday afternoon, all 500 tests passed. So I had this brand new code, really, really nice looking code. Things like, I didn't even pay attention when I was writing the initial code. The things like consistent naming conventions. I had a lot of global things. Just kind of convenient things just to kind of get done. And I just said, we can't live with this. Okay? It was really neat. By Sunday afternoon, the whole thing was working. So this guy Phil, on Monday morning, like he was shocked. It's like, and I rewrote it. But at first his reaction when I said, I rewrote it, he says, no, we can't submit brand new code like that. It hasn't been thoroughly tested. So, it's going to work. Pass all the tests. I can understand it much better than I can understand the original code. So I ended up, but then I didn't end up apologizing, but I definitely just plunged ahead without asking for his permission because he definitely would not have signed on to that. I think he was picturing, and I was picturing, this is going to take me a couple more weeks to rewrite this. So anyhow, so what did I learn from that? That you can write product code quickly and well if you're not spending any time trying to figure out how things should work. And the second story is what happens when your command line syntax is incorrect. And I already kind of alluded to this story. That this was started in the 80s, and I was trying to convince them that I would do something for them. And so I had a presentation, I think it was like a Wednesday, and I worked on this code to present to them for quite a while. And Tuesday night, I was compiling it online, and I don't know if you guys are familiar with, you use the -O in the name of the object file. And I did name.c. So the object file simply had an extension .c, which meant that my C code had gotten totally overwritten. And I didn't have any backup. So in a panic, it was about 9 o'clock in the evening. By 11:30 that evening, I had everything back. In fact, it was somewhat better than the original code. So that experience also convinced me you can write product code quickly and well if you know what you're doing. So that gave me the assurance that if I told the students, wait until 10 days before your project is due to start working in your product, if you know how everything should work, you're not going to have any trouble. You should be able to, in fact, borrow a lot of your existing code and just piece things together. And the amazing thing is the project success actually demonstrated that that was true because nobody ever got green-lighted well in advance of the deadline. It was always, at most, maybe 2 weeks before the deadline. And most people managed to produce working products. All right, so writing product code quickly and well it takes some faith, but it's actually a phenomenon that exists. I've experienced it, and these students actually experienced the same thing, even though they also had doubts about being able to finish their projects. They're begging to be greenlighted. So, but I wouldn't greenlight them until they really knew what they're doing. Now I'd like to talk about what gathering knowledge means. Mostly, well, a big part of it is writing lots of code and creating lots of little programs. In fact, I discouraged them from creating one big mass program because there's two problems with that. One is if they're all working on the same code, then they're kind of stepping on each other's fingers. And the other thing is there's a temptation to just take this massive code and kind of evolve it into your product. And I didn't want that to happen. I wanted these quick and simple and quick demo programs. They could show me they could send an email with a script. That they knew how to implement a particular user interface element using HTML and CSS, or so that they didn't have a lot of setup. I insisted on these little programs, test harnesses, test suites. I guess I messed up my slides there. Okay. Another aspect of gathering knowledge is talking to customers. And once again, this is another presentation, which many of you may not need, but it's sort of the form of, it's not just sitting down and having a chat with the customer, but it's actually having a very purposeful conversation, asking them in a very structured way. The customer, you don't explain to the customer what you're doing, but you as the engineer actually have to drive the process. And the only thing the customers really, I think, delight in is telling you what you got wrong in your assumption about how the product should work. Related to this is iterating through user interface designs. Your first user interface design is never going to be right, never right. And you need to iterate oftentimes the customer doesn't care about the user interface, but there are people who are experts at user interface design that you should definitely have iterations with. So that's the process of gathering knowledge. Getting fluent with existing code, there's a number of ways to do that. One is to refactor code. Another one is to just do some small projects that fix bugs in the existing code. And at this stage, when you're gathering knowledge, what I would emphasize to the students, and I emphasize to myself, in fact, in this phase of the project I'm working on right now, I'm not worrying about writing the final code. I know that in a matter of days I can produce the final code, but I don't know everything I need to know to write the product code. So I'm not worrying about that yet. And I expect to spend lots of time here. I expect the students to spend a lot of time. They spend the bulk of their time here. Okay, well, sure. But again, I'd like to emphasize that they spend a lot of time writing code. They spend much more time writing code than talking to the customer, who was me, in part because I kind of had a pretty detailed write-up online for what features they needed to implement or modify. Okay, so now I'm kind of working backwards here. And so identifying what you don't know is, in fact, the key to success here. It's not, these other two things kind of fall out relatively naturally if you do this part adequately. And what does it mean? Well, what it means is literally what it says. You need to make a list. You need to kind of get organized. You can't just have it in your head. You need to actually put it in writing. The project I'm working on now probably is something like 30 unknowns that I'm working on. So I've resolved it to relatively, not tiny granules, but and each of the unknowns is specific enough that I can say, here's something I need, something where I can say, here are the tasks I'm going to do to work out this unknown. And it does take a lot of discipline to kind of stick with identifying before you start resolving. I know, actually, I've been here. How many developers have been in a meeting with a customer and you're already thinking, that's how I'm going to implement this, that's how I'm going to implement that. Because I've done this myself. And I'm not thinking about the big picture, I'm thinking about, the fun features and how we're going to implement them. And developers rush through this because I've done it. All right, so if you can't think of anything, this is another key thing. Start with what does the customer want. Many developers assume they know what the customer wants. That's why it's important to have a structured process for having conversations with the customer, which in fact are an iterative process. Another question is what should the user interface look like? And once again, developers oftentimes assume that this is going to be easy, they can throw something together. But today's standards are actually much higher, and that requires some work. Unless you're absolutely fluent with the code, because I know that this code that I'm rewriting to make it web-based, I look at the code I wrote 15 years ago, and I'm going like, I wrote this? What does it do? To me, it's stunning how you kid yourself that you'll remember how this works forever. And if somebody else wrote the code or modified it, then that's definitely a rich area for unknowns. And then this is the fun one, how will required features work? So that's another area that can flesh out a lot of unknowns, or where you can flesh out a lot of unknowns. So in addition to making a list and examining these areas, and there's probably more areas, it's helpful to phrase your unknowns in a particular way. Start with the phrase, what I don't know is. Like, so for example, what I don't know is how to send an email with a web script or a server script. What I don't know is how to export my document to PDF. Or what I don't know is what this code, or how to code for registration works. So unknowns have this nature that you can express them all starting with this phrase. It was particularly useful for the students because they. In fact, well, the thing is, when I write my unknowns, I write this phrase because it just kind of puts you in the right mindset. Like if it doesn't sound right, then it's probably not an unknown. And so I want to show you some concrete examples. You can be general and say what I don't know is what the customer wants. But that's too general. So something a little better is, what I don't know is how the customer wants account registration to work. So then you can have a conversation with the customer about that specific feature. It's not too narrow, and it's not too general. And then you can end up writing some use cases or scenarios about how registration works. Some hypothetical person registers for an account. You give that to your customer, and the customer says, "Wait a second, that's not how I want it to work." Okay, well, how do you want it to work? The customer tells you, and then you go and modify the story, and it converges to something that both you and the customer are very clear about and agree on. Here's another general one, which is I don't know what the user interface should look like. The better one is what the user interface for account registration should look like. But once again, it's kind of like the Goldilocks criterion. It's not too broad and it's not too narrow. It's a conversation you can have with the user interface design expert, or possibly even the customer. The customer may not care. Once again, a general and specific. I typically have the students break down technical things like this so that there's a single focus thing that could be implemented with kind of a small program. You can write a program. Actually, you need to write several scripts. There's some JavaScript, some server scripts to demonstrate that you can get a browser to send data to a server and not blink. Or send an email. Or this is maybe a little too general, maybe not. How the existing code for logging in works. That's so once again, you can say what I don't know is how that existing code works. So hopefully it's clear that you can pretty quickly come up with a very long list. Put a box out here, which eventually check off. Okay, so there's several rules of thumb. Specific is better than general. Typically, students would try to be quick and general. Think they could get on to working on sort of resolving things. But their list was too short, so I made them kind of break down their general things into specific unknowns. So, for example, this is reduced to that and a bunch of other things. And another rule of thumb is make sure that you sort of spend enough time on this. That as soon as you decide to start resolving some unknown, you probably aren't going to be able to go back and say, okay, what else don't I know? It's kind of one of those developers can kind of relate to this, that they get kind of immersed in one technical issue and they no longer kind of thinking about the big picture. And if you don't have pages of unknowns, you haven't been thorough enough. All right, so resolving unknowns is kind of the fun part, which is the gathering knowledge. Once again, the general unknown, you can discuss it with the customer, but that will probably be a pretty long conversation. So it's better to use, to kind of break things down specifically and talk to the customer specifically about this feature. And once again, we discuss it with them in this particular structured way, where you end up with scenarios that define precisely how registration should work. So you write scenarios, review them with the customer, revise them, and then keep repeating this process until you converge to something that the customer likes, or what the user interface should look like. you first create a paper user interface and review it with, review it with somebody who's knowledgeable. Then you revise it and repeat. So it's iterative. It's very much in the sort of agile spirit, in the sense that you're not going to get it right. You can't plan it from the beginning. You need to iterate. But the unknowns then provide you with the context for the iterations. For the existing code, you can do things like just stare at it or discuss it. One of the things I like doing is single-stepping through the code with a debugger. So not only do you see where things go, but you can look at the data. It actually tells you a lot. And you can also refactor it. It's amazing how much you can learn about code, how it works, simply just by kind of cleaning it up, not changing its functionality. Right? How to send email with a server script. Now first you Google. Like my online students, they spend a third of the time Googling. And then you just write some small program, the trick. And then the thing I've learned is because you're going to set this thing aside and move on to another unknown, you might forget some of the things that you learned in the process of resolving this unknown. So it's good to write some notes so that you remember. Like you might need some particular, Apache server settings, to get this particular script to work. And if you don't write that up, you may end up having to kind of figure that out again. And so basically spend the bulk of your project working, resolving, getting this knowledge. And the question is, does this technique scale? Right. I'm going to kind of leave that question open, for you guys to, I just go by the data that I have. It certainly works in the context of my BU class, and it definitely works in the context of my own software development. But neither one of those are really large groups. But intuitively for me, I'd be inclined to say that even if you're doing something like planning a mission to Mars, it'd be a pretty good approach to kind of making sure that you have enough knowledge to build a complete system that succeeds. So, and do I use this technique? Do I dog food this technique? In a way, I've always done it, but after this, the word unknown didn't really hit me until this incident or this evening, where I eavesdropped on the group. But I've always, I guess I'm a worrier. So I want to make sure that I know how I'm going to implement everything in a product before I actually start working on the product. So now I really formally use this technique of making the list of unknowns, resolving the unknowns before I work on the product. All right. So this was before the unknown approach, and that was, you can't say it any more simply than this was after using this approach. And it wasn't having them work on product code or even having them resolve the unknowns, but it was all the meetings we had, we talked about unknowns. Mark?
Interesting. I see a connection or resemblance to another theory or area, which is known as mastership.
Yes.
Mastership says that all human areas, there are masters, and the master of a skill is better than a journeyman, because when he looks at a problem, he immediately knows how to do things. And the other, related to that, is there also that it takes about 10 years for someone to become a master in an area. And most people never do, because once they reach the journeyman level, they give up learning things. So I'm seeing the resemblance that maybe this means that a master in an area has no more unknowns.
think that they just have unknowns on a different level. But for normal things, yes, I would agree.
Normal actions.
Just to pick up on what he's talking about, his focus here is on people gathering and retaining knowledge.
Mhm.
When I was a software developer, what I tended to do was to maintain an inventory of code fragments. Like what you're talking about.
Okay. So you discovered this.
Yes, discovering the unknowns, you're writing little test programs,
Mhm.
but one thing to write test programs, and then they're associated with a certain project, but it disappears over time, and then you lose the knowledge
Mhm.
unless you maintain this inventory of code fragments. What it's hard to do, it's really hard to get management to buy into this approach. Because it was always, for me, what I was always a proponent of is prototyping leading to productization.
Right. So
It's very hard to say.
right. In fact, there's nothing I'm saying today that's new, and you proved this. And I was fortunate that basically BU kind of gave me a blank slate. The only thing I had to do was assign projects. So I didn't have management to say, well, we don't feel comfortable with you doing it this way. So I felt really fortunate that I had this environment where I could just experiment in this fashion. And it turned out that, wow, this works.
These days, actually, it's better tools to maintain that inventory back in the day.
Mhm.
But we didn't have a share.
Right, right. The take notes part kind of helped. So like they had to create readmes with their little programs to at least mention the, by the way, you need to turn on some feature in the Apache server or the script is not going to work.
These days, you can grab a screenshot, a couple of bullets, and talk about the table.
Right.
How does architecting and creating an architecture of Rick, do you do this along the way? Are you doing this first?
I'm glad you asked that because one of the unknowns, in fact, the last time around, they had to change the architecture. This kid who wrote it back in like 2006 had kind of created this mess, and I felt it was high time to restructure this into a more well-defined architecture. So one of the unknowns is what architecture should we use? And one team member was assigned the work of creating a mini implementation of the architecture just to demonstrate that all the pieces would fit together.
Prototype.
He didn't, right, exactly. He didn't implement the whole system, but he just implemented it enough to convince themselves. They basically converted to one level model view controller, because initially it was one big blob. And they convinced themselves, yeah, we can have this model layer, we can have this view layer, a control layer, and we know what code goes in each one of these layers, and it's going to work. And they needed to do this to convince themselves that yeah, this is going to work in general. Right. So you can do things like kind of convince yourself that your assumption about the architecture is correct without actually building the whole system. So, but it was the first few weeks, making them think about what they don't know, which was the key to the project success. Because all the meetings we had after that were, what unknown are you working on? What unknown did you resolve and can prove to me you've resolved? And those were really the only two topics we talked about for the bulk of the term. And only until the entire list of unknowns was checked off did they actually start working on their product. And they probably most of them used their little architecture prototype at the beginning of the product. But, but the point was they had all this knowledge. So I'm sorry, there was a gentleman back there.
Yeah, it makes a lot of sense, the presentation, and it kind of echoes, going back to the basic way of writing programs from requirements, and these eager students want to go into coding, but there should be a step before, maybe call it design, Think about the design, and this is answering the question, what are the unknowns, so you kind of think about how the design's going to be going, and then you can go into coding. So.
Right, and the conversations with the customer is really where the requirements come from, because have you ever written scenarios like like product design with the customer where you write these little scenarios? Joe is an accountant, Joe needs to do an accounts payable report. Joe logs in. Joe, right, exactly. Right, and if you have something in that narrative that the customer says, no, that's not how we want it to work, you can immediately correct it. Okay, and the requirements fall out of that, because not only do those little stories enumerate the features you need to implement, but also they kind of identify kind of sub features, things like logging in, things like generating a particular report. So then you can then harvest out of these stories the requirements. So you don't have to ask the customer, what are the requirements? They can't tell you. But you as an engineer can then kind of comb through these things and kind of harvest all the requirements out. And I'm not sure you had this.
Work, if this were really new stuff, let's say Sarbanes-Oxley, right after Sarbanes and Oxley got the law passed, or healthcare right after the Affordable Care Act was up, and didn't quite know about the record keeping, and nobody knew.
Let me ask you this: what's an unknown there?
Everything.
Everything.
It's
Now, how do you work? Let's say Sarbanes-Oxley, a half a year in.
Well, well, the unknown is, what I don't know is what Sarbanes-Oxley means, or how it applies to a particular aspect of a business. So the only way you're going to get to the bottom there is to actually study the law and understand what that means.
understand what you're already doing.
That's it. That's right. Right. And somebody else have a question?
In your abstract, you mentioned estimated time required.
That's another presentation. In short, if you have an unknown, you can identify the tasks you need to do to carry out to resolve the unknown. And then once you have those tasks, you probably are now zeroing in on reasonable estimates for how long those tasks will take you. And if you can't estimate the tasks are probably too general. So you need to break those down. A good example might be, I need to export a document to PDF. Okay, so what tasks would you do if you knew nothing about, you say you can program in C and know that, there's some way to do this in C. How would you go about resolving this unknown? You personally, if you were to do it. What tasks would you imagine having to do? And let's say there's a library somewhere available, but you've never used it.
See what functions are available in the library, what can be put together to accomplish.
Okay, and could you estimate kind of how long this would take you?
Well, you know what you're looking for.
Okay, but compare that to not breaking it down into tasks.
I would say is that a small task generally is easier to estimate time for, so that if you've broken your large task into small ones, you're confident that that set of small tasks together is complete, and you could do your estimation that way.
Right, and this dovetails very nicely with sprints, because you're only estimating for 2 weeks or 3 weeks. So you're not like breaking down, a huge project into tiny tasks. It's just, I'm going to work on this unknown. Here are the tasks. Here are the tasks I think I can do in this sprint, and that's the end of it. So, in fact, this other things which are other presentations, and I'm sure you guys wouldn't want to sit for another several hours. By the way, this course was 2 3/4 hours. And when the first year I taught it, they didn't even give the kids a break.
Yeah.
It's not supposed to teach like lecture for 2.5. Well, technically it was 3 hours, but they said that you're always given 15 minutes to get to the next class. So I'm not sure if that was true or not. I always let them go 15 minutes early. But in any event, so you guys are getting off easy here. But anyhow, one of the things that unknowns lead to is much better estimation. Because I don't know about you guys, but how many of you do this, but most of my software development work has been as a contractor where I bid on a project, or at least provide an estimate for a project, how long it's going to take. I have to provide a schedule before they even commit to the project. And so by using this kind of technique where you identify the unknowns, you have a much better idea of the scope of the project. So it turns out it's much easier to estimate. And it's much easier to communicate. I wish I had more time to talk about this, because one of the, I think one of the challenges, even throughout my whole professional career and teaching, is talking to somebody about software they're working on. Because they're very quick to say, yeah, it's going well, or just say some meaningless things. It's amazing. Like, I'd be like a team leader, and every Monday morning we'd have our status meeting, go around the table, everybody would say these meaningless things. And I didn't really have time to say, like, can you tell me something meaningful? But if you talk about, like, so, can you demonstrate your little program to write out PDF? Either they can or they can't. There's no more discussion of some, yeah, the PDF thing's going well, but, so, and they don't have to actually implement it in the product, they just have to show me a little program that does it. So, the communication between developers and team leaders, it also is helpful in some cases between developers and customers, where the customers actually kind of get involved in the things that need to be sort of figured out. And also between developers and developers. It's kind of cool eventually to hear my students talking to each other about unknowns, because they're having relatively effective and efficient conversations. They're talking about kind of what I would consider, real things, talking about, so, do you have your, mail script working? And this is probably maybe even more appealing. That I don't know about you guys, okay? But I've worked in a lot of environments where Agile is used, and I see a lot of passive-aggressive behavior when it comes to things like, stand-ups, kind of going through the Agile routine. But the amazing thing with this is that developers like talking about, my script for sending email is not working. Well, show that to me. Like they all get very engaged in talking about unknowns and resolving unknowns. So it's something that can really inject energy into an agile environment, because it's sort of so developers don't feel like they're just kind of going through some prescribed motions. It's kind of what's real to them problem. The bottom line is kind of identifying problems and solving problems. So since I don't have time to do all these presentations, if anybody wants to know more, the easiest way to contact me is just email me. There's the email in the corner. This is going to be online. Tom will put it online in short order. So I appreciate your time and attention. It's something valuable. Hopefully you can talk your management into attempting this. I'm happy to come and give your company a talk on this and related things. There are lots of questions already, but if there are any more, I'd be happy to answer them.
You said, like, we're a contractor or a consultant, and you're talking to a potential client about doing something. How do you get them to realize that 3/4 of the time that you're working for them, and the first 3/4, you're not doing any of the final code, and they better accept that? Can you get them to feel good about committing to a project that way?
You have to be kind of a magician and create an illusion. I don't explicitly tell them that I'm using this method, and I certainly don't alarm them by saying, "Well, I'm not going to write any product code until 3/4 of the way through the project." I tend to mostly communicate with status reports and communicate that certain things are working. I tend not to demo, although sometimes you get in a situation where they want you to demo something. which then it's very difficult to sort of the illusion, keep the illusion. But for the most part, I think it's just because of past success. The status reports kind of are adequate, or to give them a sense that things are going well. Because like if, a customer that gets surprised at the end generally doesn't hire you again.
I do see one difference in what you described in your coursework versus that. As I understand what you described, you're saving the integration piece from the very end.
Yes.
So you're writing all the test programs up front and along the way, and then you get to the bitter end, and suddenly it's like, okay, let's plug all these things together and make them all work, which requires a lot of work with interface.
Mm-hmm. That's the key word.
And using what the test program is very specific to the actual product. Agile really promotes that integration work along the way. You're not really waiting until the end because you're kind of building up
I completely agree.
bigger product.
Right.
That at any moment in time you may say this is good enough, and we know what the full scope is supposed to be, but quite often it's time lost, and you have to say, for this client that we're working with, or this customer segment, this is good enough for them, and maybe some of that other less important, less priority stuff just won't be done.
I'm going to play devil's advocate. One of the reasons people like this continual integration is they know that the interfaces are all right. Right? And you're also saying, well, there's some features that don't get incorporated. So that if you take the approach of designing the interface up front, the interface may address some features that you never implement just because there's not enough time.
Well,
Right.
Agile teaches as a practical matter, companies will often lay out a lot of things they want, which may not actually be all that important. And for the amount of time that it takes to develop the entire scope, the world changes out from underneath. So by the time, let's say it's a 9-month duration to develop everything, within that 9-month period, things change. They may not need the same things that they did from day one. So the argument is, most companies are looking for things in time blocks that want to deliver by that date. What you can promise them is that I'm going to deliver the most important stuff because we prioritize this all the time. We get constant feedback from the customers. So there may be some things that get locked off from the original scope, but ultimately you're getting the most important stuff, not stuff that you won't use anyway, which the traditional approach, waterfall, has a tendency to look at things.
Yeah, I just want to respond once, and we need to wrap up here. We need to be done by 8:30. So to answer your question, the nature of the projects that work well with this approach, and which is my general approach, is that you can basically clearly define what changes, what additions you want to make in a particular cycle of a product. If it's a product that sort of is kind of relatively vaguely defined and it's going to kind of meander all over the place based on what the customer sees kind of midway, then it's much harder to kind of design the interfaces up, basically early on, prove them out, everybody do their development sort of in separate pieces and then integrate at the end. So for the projects where you're kind of figuring out where things should go, I think there's, the unknowns still apply, but you have to kind of think about the project a little bit differently. Most of what I'm talking about is things where you have a pretty clear destination. And so one of the unknowns is what should the interfaces be? And then you can write, once again, some little programs that sort of define the interfaces, test out the interfaces, make sure that maybe things are fast enough. Okay, any other questions? Or
Is this, what are your views of behavior-driven development and test-driven development? How does it fall?
This is heavily test-driven development because the little programs need to pass one or more tests. in order for the project to really be qualified as done. But actually, not the project qualified as done, but that particular unknown to be qualified as resolved. So there's, you actually identify the things that software needs to accomplish for that unknown before you actually write the software. Behavior-driven development, remind me sort of specifically.
It's getting the requirements spec'd out, typically with like the Gherkin language, where you
Oh, I see.
And you spec out the user categories essentially first, and then you write the tests, which
Okay.
you include in
Right.
testing, and you write the tests to the
Right.
behavior or you define it.
We didn't specifically do that, but there's no reason why the stuff that's demoed couldn't be that stuff. Alrighty, we have to wrap up there?
Just about on time. Thank you.
Okay. Well, thank you all. Very good questions, actually. I really appreciate it.